In section 3-1, we are solving systems of equations. Now, a system of equation is literally where we have two or more equations, okay? And they are giving us values of x and y, and we're solving for x and y, okay? We're solving for x and y in all those equations. So, a system of equation is two or more equations. We are dealing with linear systems. They're called linear systems. Why do you suppose? Because we're talking about equations of lines. Okay? Linear means lines. So a linear system of equations deals with lines. We're going to eventually work with three different ways of solving linear systems. Okay? Today we're going to focus on one method, which is graphing only. Okay? So solving a linear system of equations by graphing. What we want to do is graph each equation separately. Okay? So there's our system. And by the way, that little bracket up there, that just shows you that that system is together. We're trying to solve this together, not individually. Okay? And also give you a nice little hint. It took me years of college to figure this one out. But making nice braces or nice brackets, because I know a lot of yours are going to look like this. Try it right now. I bet they look like that. Okay? So, make a nice brace. All right? All right. So, the trick to making these is draw an S and draw a 2. That's all it is. It's an S and a 2. You want to close the brace? Do a 2 and then an S.
Wait, it took you college years to
I'm slow. Yeah. Uh-huh. I didn't have a teacher to show me how to do it. It took years of practice until I finally figured out, oh, wait a minute, I can draw those nicely if I just do an S and a 2. Anyways, you're welcome. So, we are dealing with a system of equations, system of linear equations, and what we want to do is graph them. So we're going to take that first equation, and I will literally call that equation number 1. And so working with equation number 1, we have negative 3x plus 2y equals 8. And I want to graph it, so I need to rewrite it in what form? Slope-intercept form. So to get it in that form, now that looks like a dot, but that is a negative 3x. So we need to add 3x to both sides. That gives me 2y equals 3x plus 8. Well, now I need to get the 2 by itself. Yes, sir? All right, so now I need to divide by 2. And please remember on the right side, when I'm dividing everything by 2, that means I get 3 halves x plus 4. All right, so I can go ahead then and graph that equation. I'm going to go to 4 on my y-axis, because that is my y-intercept. And then I'm going to count a slope of 3 halves. So I'm going to go up 3 to the right 2. I want to go all the way across my graph. So I'm going to go down 3, left 2 as well. All right, we just graph it like always. Use a nice straight edge to draw a nice straight line. Yeah, for going by hand, that's not so bad. All right? So, there's our first line. Well, we obviously have 2. So we need to solve the second system the same way we did the first. Or the second equation, we're just going to graph it. So we have x plus 2y equals negative 8. So equation number 2, x plus 2y equals negative 8. We want that in slope-intercept form. Now, this particular equation, would we have to put it in slope-intercept form? No. Anybody know why we wouldn't have to? No? What form is it in? It's in standard form. Absolutely. And we learned how to graph it from standard form by finding the intercepts, x and y intercepts, right? And we said that finding x and y intercepts can always be done, but it's an easy method only when the C value is divisible by both the A and the B value, right? Well, -8 is divisible by 1, of course, and -8 is divisible by 2, so we could simply graph this by finding the x and y intercepts. I will remind you how to do that now. So the x-intercept is located at something, comma, 0, always. For the x-intercept, the y-coordinate is 0. For the y-intercept, the x-coordinate is always 0. So, we use that cover-up method. I'm going to come up to my equation. I'm going to plug 0 in for y, which essentially covers it up. So what's x equal? -8. Then I'm going to plug in 0 for x. So that goes away. So I get 2y equals -8. So what does y equal? -4. All right, so there's our x and y intercepts. We can plot those points. I'll graph this one in blue. So on the x-axis, -8 is right here. And on the y-axis, -4 is right there. And so a line through that is going to be my line. Now, I don't have a straight edge here, so I'm going to want to plot more points that I can draw a straight line. And so counting this, I go down 4 to the right 8 to get to my other point. Well, let's see, -4 over 8, doesn't that reduce down to something? Yeah, -1/2. Down 1, right 2. Down 1, right 2, down 1, right 2, so on and so forth, so that I can graph my line more easily. Okay, so there's our system of equations graphed. Now, we are looking for the solution to this system. So that means we're looking for an x value and a y value that satisfies both equations.
On problem number 2.
Whoa, we're not there yet.
No.
On problem number 1, I mean equation number 2. Okay.
Number 2, can you go to the y-intercept form?
I will in just a moment. Yep. Okay, so looking at the graphs then, where do you suppose we're going to find the solution to the x and y value that satisfies both equations? Where they cross. This point right there is an x value and a y value that works on both equations. Because let's talk about graphing for just a moment. When we are graphing an equation, what are we finding? We are finding all the points. We are finding all the points on this blue line, every x and y coordinate that satisfies that equation. In the black line, we're finding every x and y coordinate, every combination of x and y that satisfy the first equation. And so we're looking for that one point, that one value of x and y that satisfies both equations. And so, of course, that's where the two lines cross. Okay? And so the answer to this problem, the solution, are the coordinates -4, -2.
So -4, -2 would be final answer.
That is the final answer. That is the solution to that system. Yes. All right. So let's take a look at another example. Third one? Sure. All right. Third one says, you bought a total of 6 pens and pencils for $4. Now, be careful. You bought a total of 6 pens and pencils. Right? You got to be careful on the language on that one. For $4. If each pen costs $1 and each pencil costs 50 cents, how many pens and pencils did you buy? We need to write a system of equations. Okay? So our first equation, and by the way, let's see here. Pens and pencils. Let's give variables there. Since our graph is in x and y, let's have pens and pencils be in x and y. All right? So let's have pens be x, pencils be y. Okay? And once we have that, x and y is going to be the number of pens and pencils. So one equation we can write is the total number of pens and pencils. Ignore money. Okay? So if I take the number of pens, x, plus the number of pencils, y, what am I going to get?
6.
I have a total of 6 pens and pencils. So I know one equation is x plus y equals 6. Yes? Everybody cool with that? Understand where I got that from? Cool. Now let's talk money. Now let's talk money. A pen costs $1. Better be a nice pen. All right? And a pencil costs 50 cents. So, and it says that we spent $4. Total of $4. So let's have that be what it equals, right? It's going to equal $4. How would I, let's stop for a moment. If I bought nothing but pens, how would I write an equation for the number of pens I bought?
X equals 6.
X equals 4. It's $4, right? We're talking money. I'm totally standing in your way. It's $4 because we're talking money. And so X would equal 4. Okay? What if I bought nothing but pencils? Y would not equal 4. Y, what did you say about that?
I just said it'd be
0.5y equals 4. We would actually, if I bought nothing but pencils and I spent $4, I actually have 8 pencils. Right? They're 50 cents a piece. And so it's 0.5 times 8 equals 4. 0.5 is 1/2. Everybody with me? Seeing the logic there?
Mm-hmm.
Well, now I'm going to have a combination of the two. And so we said, okay, 1x equals 4 if I buy all pens. 0.5y equals 4 if I bought all pencils. And so if I have a combination of pens and pencils, I should probably say 1x plus, and I'll write 1/2 rather than 0.5, y equals 4. $1 for every pen, 50 cents for every pencil. Some combination of the two gives me $4. Make sense? Where I got that from, everybody? All right, so that is our system. All right, we put the brace on there to show that we're solving these together. Okay? We're solving these together. Well, now that we have it written, now it's just like the first example we did. We just need to graph those two lines. So the first one is written in standard form, and that should be pretty easy to graph. Do you guys want to put it in slope-intercept form or graph by intercepts? Okay, slope-intercept form. So equation number 1, x plus y equals 6. I need to subtract x from both sides. So y equals negative x plus 6. Where's my y-intercept? 6. What's my slope?
1.
It is not 1.
-1.
It's negative 1. So 6 is the y-intercept, and I'm going to go down 1, right 1. Or up 1, left 1. And I draw my line. Again, a straight edge is going to be very important on this. All right? It's difficult to use a straight edge with the iPad, so I'm not, but I would appreciate you guys doing that. Equation 2. If we're writing this in slope-intercept form, then I'm going to subtract x from both sides. Let me write down the equation first, I guess. X plus 1/2 y equals 4. Subtracting x from both sides gives me 1/2 y equals negative x plus 4. How am I going to get rid of the 1/2? Multiply by 2. I don't divide by fractions. We never divide by fractions. We multiply by their reciprocal. Good job. So we're going to multiply by 2. That means I multiply everything on the other side by 2. 2 times 1/2 gives me 1y. And I need to distribute the 2 through there. So I get negative 2x plus 8. All right, so there's my second equation. Graphing that, I'll graph that one in blue. We have positive 8 is the y-intercept, and our slope is negative 2. So I'm going down 2 to the right 1. Down 2, right 1, down 2, right 1, so on and so forth. Yeah, and I'm going to finish graphing it, but we already know where the solution is going to be, right?
Yeah, I already knew that.
And that was the answer you gave?
Yeah, 2, 4. Yes. No, I actually put it in my head.
Well, 2, 4 is wrong. Oh, no, I was looking at the right one. Sorry. Yeah, 2, 4 is right. I was looking at the wrong point. I was looking up there, and I was like, well, 2, 4 is not right. Oops. Yeah, absolutely. Right there. Right there is our intersection, and that is at the coordinate 2, 4. Very good. 2 pens, 4 pencils.